Hello, students. This is your tutorial on the Unit 3, Day 12 ionic bonding pair deck. So we did this in class, but I wanted to be able to back up some of this stuff, and since we didn't get through everything, I just want to give a little tutorial of what you should be able to see on your pair deck. So I'm going to draw the Lewis structure for the bond between magnesium and sulfur. Starting out, I've got my magnesium. Magnesium, if I look at it on the periodic table, I'm going to have 2 valence electrons, so I'm going to have 2 dots. And sulfur is going to have 6, because it's in group 6 or 16, depending on how you're looking at it. But it needs 2 valence electrons, so I'm going to take this, and this electron, I'm going to bond it to sulfur. So that's what it would look like for the structure between magnesium and sulfur. And so then I've got the formula and the name. So the name on here would be, so I can just type this. I could type the name. First of all, the formula would be MgS. So that would give you the formula, because there's just 1 magnesium and 1 sulfur. And the name for it would be magnesium, same first name, but the sulfur would not be sulfuride, but it would be sulfide. If you write sulfuride on the assessment, you will also have an opportunity to, I'll give you credit for that, but it is sulfide. Then moving on to our next example on this pair deck. The next one that we had were calcium and bromine. So calcium, I've got, I need to click back over to our marker. So calcium, that is not the right color. Let's do this color. So calcium is also going to have 2 valence electrons. It's just below magnesium on the periodic table. So calcium and then bromine. And notice calcium needs to get rid of both of those electrons. And then we've got bromine. Here we go. Bromine, it has 7, is in group 7 or 17. And this calcium is going to give away its electron. But bromine can't have more than 1. It has to, because otherwise it's going to be overloaded and then it will not work. So then what happens is that bromine comes along and says, all right, calcium still wants to give away another electron. And so another bromine comes around. And in order to balance this bond, in order for this to even actually happen, another bromine would show up. So then you'll see that there is 1 calcium and 2 bromines. So that will get us to our formula and our name. So the formula, I'm just going to draw because it's a little bit easier than typing, but our calcium is there is 1 calcium. So we have 1 calcium. I don't need to write the number 1. So you don't ever write the number 1 whenever you're writing a formula. So you just can leave that. So, but then if you have 2 bromines, you do need to indicate that you have 2 bromines. Notice I am writing a capital B and a lowercase r, and I'm going to have a 2 down below. And so that's the formula. And the name for this, I will type this, is going to be calcium bromide. And you don't have to capitalize it, but I tend to capitalize things often. So on there. And here is another example. Another example on here, we've got sodium and oxygen. So sodium, looking on the periodic table, you're going to see that sodium has 1 valence electron. Sodium is Na, uppercase N, lowercase a. Got it, 1 valence electron. And oxygen has 6. So it's going to have 6 valence electrons. It's in group 6. And so then sodium is like, all right, I'm going to give my electron to oxygen. But oxygen now only has 7. So it has 1, 2, 3, 4, 5, 6, and 7 because sodium gave it. So then, similar to that bromine did with the calcium, is another sodium is going to show up to make sure that that oxygen is going to get what it needs. And it's going to have 2 arrows going towards that oxygen. So notice there's 2 sodiums for 1 oxygen. So to write this formula and the name, you would have Na, uppercase N, lowercase a, the little 2 below, and an O for oxygen. But this is not oxygen. This is now become sodium oxide. Oh, oxide. Great. So that is for sodium and oxygen. I'm going to skip over the aluminum and bromine because we did that one in class, but I did want to show you one of the challenge question that is going to be similar to the challenge question that's going to be on the assessment. Is we got magnesium and nitrogen. Some of you did this, but you're going to end up having magnesium having, I need to get that number. Here we go. We got magnesium is going to have 2 valence electrons. So I'm going to draw those 2 valence electrons. Could have a little bit smaller pen, which this works for now. And then I've got nitrogen. And you're like, why did she write 2 of those? So just to get us started, so we've got a magnesium giving an electron here, another magnesium, because nitrogen wants to have a total of 3, then magnesium is going to give another one from here. But then this magnesium still needs to have another nitrogen. So there'll be another nitrogen. And then this magnesium is like, okay. But then this nitrogen still needs 2 more. So you're going to end up seeing even 1 more magnesium show up with its electrons to then give 2 nitrogen. So you'll see 1, 2, 3 magnesium and 2 nitrogen. So the formula and the name is coming here. The formula for magnesium and nitrogen together would be Mg3 and N2. It's a little trickier. I won't have one like that on the assessment except for a challenge, but the name for it would be magnesium nitride. All right, so there's those on your what we did in class. One of the things I want to make sure you're also able to do is drawing a Lewis structure for an element with 6 valence electrons. So remembering we are not paying attention to these at all. We are not paying attention to those. So we go 1, 2, 3, 4, 5, 6. So anything in this column, anything in that group, so I could do S, and I'd have, here is a Lewis structure for an element with 6 valence electrons. I just realized that I spelled valence wrong. And then moving to this question, draw the Lewis dot structure for calcium. Does calcium gain or lose electrons? Remembering that calcium is right here. Calcium, so calcium, it's going to have 2 valence electrons and it's going to give away 2. So remembering giving away these nasty little electrons, it's going to make it positive. So calcium, so the charge on calcium at this point is then going to be a calcium with a 2+, or a +2, however you want to say it. And then on this one, sulfur is going to be, there's those 6 valence electrons, and it's just only needs a couple more to have 8. How many more does it need to have? It needs to have 2 more. So it's going to steal 2 more. So there's from somewhere, from some metal, it's going to gain 2 electrons. So it's going to be a more negative. So it's going to be a S2 minus or an S minus 2, however you want to write it. And so I'm going to give you one more example. And I'm going to do sodium and phosphorus. Drawing the Lewis structure for the bond between sodium and phosphorus. So I've got sodium, again, is Na. I'm going to draw in quite a few places. Phosphorus is right here in this column, looking at the periodic table. So we've got P. So P, phosphorus, it has 1, 2, 3, 4, 5. So it's going to have 5. And sodium only has 1 to give. So then another sodium is going to show up to give away its electron to phosphorus, but phosphorus still needs another one. So it would have Na with an electron moving to phosphorus. So you'd have phosphorus with 3 arrows coming for it, and then the sodium giving away 1 each. So there's more in this Peardeck, but I just wanted to give you an overview of some of the things. So please reach out if you have any questions. I'm around during our office hours, during my office hours in the afternoons. You can check the Canvas, you can check the remind messages about the times that I'm available, but please be in contact if you have any questions.